Hello viewers, welcome back to the Spring AI from Zero to Hero series. In our last session, we got Gemini talking. Today, we make it remember. We are moving from a simple stateless bot to a sophisticated stateful AI microservice with persistent memory. Let's dive into the architecture. In step 1, we will define the storage. Before the AI can remember, we need a vault to store the conversation. We are implementing an InMemoryChatMemory bean. This acts as a high-speed, thread-safe cache that holds the dialogue history for every unique user session. But viewers, why are we using InMemoryChatMemory instead of just a standard Java list? The answer is a list works for one person, while chat memory is designed for scale. It's a managed bean that Spring AI uses to automatically categorize messages by chat_ID. Since we have virtual threads enabled, this memory bean ensures that even with thousands of concurrent users, their histories never get mixed up. In step 2, which is the logic engine, we are now upgrading our Gemini service. Instead of manually sending history, we use a MessageChatMemoryAdvisor. This is a powerful interceptor that sits between our code and the Gemini API, automatically injecting the past context into every new prompt. But viewers, how does the AI actually see the previous messages? Viewers, this is the point where the advisor pattern comes in. When a request hits the service, the advisor intercepts it, looks up the user's ID in our memory bean, and wraps the new question with the last 10 exchanges. Gemini receives a full story, not just a single sentence. It's like giving the AI a short-term memory transplant. In the third step, we are updating the REST controller to accept a userId. In a real-world microservice, this allows our single application to maintain separate private conversations for every person who connects to our API. But here is a question: what happens if two users chat at the exact same time? So viewers, that's the beauty of our design. By passing a userId as a parameter, we tell the advisor exactly which drawer of memory to open. And because we are using virtual threads, the server doesn't break a sweat handling both requests simultaneously. One user could be asking about Java, while another asks about React, and the AI keeps both contexts perfectly separated. And finally, in step 4, we are enabling debug logging for the advisor. This is crucial for developers because it lets us see the invisible work the advisor is doing in the terminal, showing exactly what history is being sent to the Google Gen AI servers. But viewers, most of the times we see the API key is null as an error. How do we actually know that key is working or not? And the answer is, we check the logs by setting our logging level to debug. Our terminal becomes a window into the AI's mind. You'll see the advisor fetching the history and the system prompt we defined. If the memory is empty, the logs will tell you. If the API key is missing, the logs will show you. Never guess, always log. We will explore how to make this memory permanent by connecting a database. So, viewers, Now we will implement all these 4 steps inside our existing project, which is spring_AI_demo. We will open the project in Visual Studio Code. Viewers, navigate to your source, main Java folder. Then create the configuration package and inside it create the AI config file. Now start by defining package and then import the necessary Spring AI memory and configuration classes. Mark the class with the add configuration annotation. So, Spring knows this is a setup file. Inside, we define a bean for chat memory. This bean returns a new in-memory, chat memory, which provides high-speed RAM storage to hold our conversation context during the current session. But viewers, we have got error on import and usage of in-memory chat memory. So go inside the pom.xml and see that the version of Spring AI in our project, it is 1.1.2, and viewers, we were using old method. In version 1.1.2, the chat memory architecture is more modular. We now separate the storage from the logic. First, we create an in-memory chat memory repository, which acts as our raw storage. Then, we return a message window chat memory. We use the builder to link it to our repository and set a maximum of 10 messages. This sliding window ensures we stay within our token limits while giving the AI enough context to remember the conversation. Now, move to the source, main Java service package, and open Gemini service. This file exists from our last session, so we will be upgrading its logic. We begin with our package declaration and imports for logging, the chat client, and our new memory advisor. Notice the static import for conversation ID, which is the official constant used in version 1.1.2 for identifying unique user dialogues. Inside the Gemini service, we declare our logger, the chat client, and the chat memory storage fields. In the constructor, we now inject both the chat client builder and our chat memory bean to ensure our service has access to the conversation storage. The builder itself gets 2 major upgrades. We use the .default system method to set a permanent identity, telling Gemini it is a senior Java developer assistant. Then, we attach the .default advisor's message. This is the engine that automatically handles the retrieval and storage of past messages, keeping our dialogue fluid and context-aware. In the generate response method, we track our execution by logging the thread name and the user ID. We then return the result of the chat client prompt. Notice how we use the advisor's method to bind the request to our conversation ID constant. This ensures that Gemini only sees the history belonging to the current user, preventing context leakage between different sessions. Finally, we implement the clear history method. This allows us to call .clear on our memory bean for a specific user ID. We add a log statement to confirm the action, giving our API a reliable way to reset the conversation state whenever a user wants a fresh start. Navigate to the source main Java controller package and open AI controller. We will modify our existing endpoint to support user-specific memory. After our package and imports, we keep the at-rest controller and the request mapping for our AI API. We inject our updated Gemini service through the constructor. In the chat get mapping, we add a second request param for user ID with a default value of default user. This ID is passed to our service to keep conversations isolated between different users. We also add a delete mapping for the memory path to wipe the memory for a specific ID. Finally, go to Source, Main, Resources and open the application.properties file. We keep our existing settings for virtual threads and our Gemini API key. We now add a new line to set the logging level for the Spring AI Advisor to debug. This allows us to see the behind-the-scenes work in the terminal, showing exactly how the memory is being injected into our prompts. So, viewers, our implementation for in-memory chat memory is complete inside Gemini service. We have also adjusted our controller. So this is the time to test the implementation. So run the Maven project. Open the browser with URL localhost port 8080. And you can see that the new interface is visible with Ask AI and Clear History buttons. First, let's establish an identity. I'll set my user I to Maverick and send a quick introduction. Behind the scenes, our GenerateResponse method is receiving this ID and the message. The MessageChatMemoryAdvisor sees the Maverick key, realizes there's no history yet, and creates a new bucket in our chat memory bean to store this interaction. Now let's test the persistence. Even after a page refresh, I'll ask the AI if it remembers me. Look at that. It knows exactly who I am. This works because our service code uses the conversation underscore ID parameter. Before the prompt ever hits Gemini, our advisor automatically retrieves those previous messages from the chat memory and injects them into the current request as context. But what about other users? If I change the ID to guest user and ask my name again, the AI is clueless. This is exactly what we want. In our Java code, the user ID acts as a unique key because guest user is a different key than Maverick. The advisor loads a completely empty history, ensuring total privacy and data separation between users. Finally, let's test our Amnesia's feature by clicking Clear History. Our frontend sends a delete request to our controller. This triggers the chatMemory.clear method in our Gemini service. Now, when I ask if it remembers me, The AI treats me like a complete stranger. Our backend has successfully wiped the slate clean for that specific ID. And viewers, there you have it. We've officially moved beyond simple stateless prompts and built a truly conversational AI assistant. By combining Spring AI's Advisor API with a managed chat memory bean, we've given our application the power to remember and manage user context. Remember, the secret here is the conversation_ID. It's the key that allows your backend to scale to thousands of users while keeping every conversation private and perfectly organized. In the next episode, we're taking things a step further. Right now, our memory lives in the server's RAM, meaning if we restart the app, the AI forgets everything. In episode 4, we're going to implement persistent storage, so your AI remembers its users even after a full system reboot. So viewers, if you found this video helpful, make sure to hit that like button and subscribe to the channel, Coding Maverick.